this lesson, you will learn how to compare different covalent compounds and their bond strength. There are three major factors that influence covalent bond strength: bond order, atomic size and bond length, and lastly, electronegativity. Let's break these factors down to better grasp the rules of the bond strength. Bond order makes around 50% of the bond strength. Single bonds are the easiest to break. Then double bonds, and the strongest are the triple bonds. A higher bond order means more shared electrons and a stronger bond because the increased electron density holds the atoms together more tightly. In ethane, carbon atoms are connected by a single bond. And in ethane, the carbon atoms share two pairs of electrons. That means a double bond. And double bond is stronger than single bond. Nitrogen molecule has a triple bond, and it is much stronger than oxygen, which has a double bond. Atomic size and bond length makes around 30% of the bond strength. The size of the atoms affect how close they can get to each other. Smaller atoms allow their orbitals to overlap more efficiently, resulting in a stronger bond. Smaller atoms generate shorter bonds. For example, in H2 molecule, the bond length is 2.7 times shorter than in chlorine molecule. Bond order also influences the bond length. Single bonds are the longest ones, and triple bonds are the shortest ones. For example, carbon-carbon single bond length is 147 picometers. Double bond is 134, and triple bond is 120. Shorter bonds are stronger because the electrons are held more tightly between the nuclei. Lastly, electronegativity, and it makes up around 20% of the bond strength. Electronegativity is an atom's ability to attract electrons. The higher the electronegativity difference, the higher the bond polarity, and thus the bond strength. For example, if we take H2O and HF bond will be stronger. The atom sizes are almost the same. However, fluorine is more electronegative than oxygen, which pulls the shared electrons more strongly towards itself, creating a very strong short bond with hydrogen. Now let's adapt these rules and compare different covalent compounds and their strengths. In first example, we have 4 molecules. What you want to do is always compare bond order first. So nitrogen has a triple bond, so it will have the strongest covalent bond. Then oxygen, because of the double bond. H2 and HCl have the same bond order. So we look at the atom sizes and electronegativity difference. HCl has a higher electronegativity difference, so the bond should be stronger. However, the atom sizes are the more important factor. The chlorine atom is a lot bigger than hydrogen, so the bond will be longer and thus weaker. Also, because the hydrogen atoms are smaller, the electron clouds can get closer together, allowing a stronger overlap. Let's look at another example and adapt the same principles. In all of these structures, the bond order is the same. So let's compare ion sizes and electronegativity differences. Regarding the sizes, fluorine is the smallest one, then chlorine, bromine, and iodine has the largest radius. Also, iodine has the smallest electronegativity, then bromine, chlorine, and fluorine. So the strongest covalent bond will be in ClF, then BrCl, Br2, and the weakest covalent bond is in E2. The most important thing is that these rules are only the guidelines for you to deduce the covalent bond strength in simple covalent compounds. There are many other things you should consider when we compare molecules like resonance structures, bond dissociation energies, hybridization, steric effects, and etc. Thank you for watching.